Jake. Happy,
Hello.
I was going to say happy Thursday, but we're splitting the dateline today. I think it's Friday morning down there, right, Peter?
Yep. As usual, ahead of time.
Nice. Look at you.
It really is Friday somewhere, huh? Yeah.
It's quite early, though. Like, there's times of the year, we've always said, oh, we haven't really had anyone from the Southern Hemisphere on, and it's mostly because everyone's located in the Southern Hemisphere at a place in which our time slot just generally doesn't work. So we got to get the right time of the year when like daylight saving time maps up correctly and it's a reasonable hour for everybody. So we did finally figure this out. This has been long awaited. You were on We Martians at least once, right? Is that correct, Jake?
A couple of years ago, we got to talk about the Venus mission, and we talked a bit about that. Yeah. It's been a while for that too. Yeah, so we're overdue, both of us, Anthony. I think for having this.
And
look forward to it.
We've just been dying to talk about mostly rocket bikes. So I feel like we haven't has not been a public reckoning of the rocket bikes since Ashley Vance's book came out. So I feel like
right.
We got to get into that. But
yeah, we're gonna have some hardball questions about rocket bikes. So I hope you're ready for that.
Totally. I can tell you everything you need to know about a rocket bike.
Yeah. Okay. Should we do some drinks first here, Anthony? You got something good there? What are you drinking?
Yeah, I'm still in my white wine world, but I'm on to the Soave now. So I'm moving around the Italian peninsula a little bit over the course of the summer. So I was like kind of it's 8 a.m.
Nobody told me that. Yeah, I know, but I mean, nobody told me that we could be drinking in this thing. I would have insisted on like a nice New Zealand Pinot Noir. That'd be great.
At 8 a.m. I love that. I love that energy that you're bringing to this. Yeah.
It's Friday, Anthony. It's Friday.
Even though I'm down in New Zealand, I kind of operate on US time anyway, so I'm up super early. So it's basically, the same time as you, as far as I'm concerned.
Okay, I love it. Do you have a brand you recommend? Do you have like a shout out for a New Zealand wine?
Oh, Mission Estate. They're very good wine.
Mission Estate.
Look that up.
Okay. Yeah. I need to go. I really want to visit New Zealand, and so having some wine recommendations will be important. Some clutch wine recommendations for sure.
There's like one New Zealand white wine that gets sold in stores in the Philadelphia area. It's Nobilo or something. Nobilo. It's like a blue label, a Sauvignon Blanc of some sort. I see it all over the place. So whoever that is got a huge distribution deal on the East Coast of the U.S. So good for them.
There you go.
Awesome. I got a fun one today. This is just a little craft beer called Bala de Plata Silver Bullet beer. It's got this really cool label. It looked like a rocket. That's the only reason I picked it out. So I went for that. Yeah, this is from
Silver
Tabasco.
Rocket on the show with Peter Beck. It's great.
That's right. Yeah, but I am repping the brand. Otherwise, though, I got this shirt on there.
Nice.
Yeah.
Yes.
And OG merchandise. I think so.
That's true. Are you drinking coffee or anything, Peter? Got nothing?
No. I can't drink coffee. It puts me to sleep. To be honest with you, I have like a millisecond high, and then I'm just instantly asleep, which is frustrating as all heck because I love the smell of coffee. I love the taste of coffee. I love everything about it, but I just can't drink it.
Can you do like a tiramisu or something?
Oh, totally. Yeah.
The guy who's like,
Maybe
I would love to drink
solution,
a Pinot Noir at 8 a.m. is also the guy who's like, coffee will put me to sleep.
No, we've already established it's not 8 a.m.
That's true.
Come on, make me sound bad. Like it is, whatever time it is there.
Body clock is not the same.
Right.
I get it.
Good.
Well, we probably should start off
yeah.
with a question of, obviously you're the rocket bike guy, but I assume these days you're making all the money from bike services. Is that fair?
Yeah. No, that would be fair.
Yeah. Like a rocket bike courier. Like you can really get the packages around a downtown core really fast.
Well, the trouble with a rocket bike is that the most unique thing about that bike was you have no steering. So if you ever see a video of me riding it, you'll notice that I kind of kick frantically off the line and get it all stable, tuck my legs up, tuck all my arms in, and then make sure it's all stable and push the button. Because if you literally have any steering angle or any lean on. It's just, think of it like a bullet. It just goes in that trajectory. So, wherever you point it, you go, and then once you lock it, you're basically just hanging on. So you have almost no control over its kind of direction. So it always looks extremely comical when you see me first start, because I'm kind of dangly legs, sort of pushing this thing to try and get it up to enough speed that I can tuck in and then go.
Desperately trying to make sure it's pointed in the right direction before you're committed.
Yes. And you found this out how? What was the learning series for that?
There was the learning curve is steep.
To put it lightly. Yeah, mostly, I mean, man, did you know when you got together with Ashley Vance that you were going to be getting into the depths of that story? Were you prepared, or did you accept the interview and you were like, oh shit, I realize now that I'm going to get into all this backstory?
Well, to be honest with you, I stonewalled Ashley for years upon years. So the amount of information that he was able to extract is impressive, given that the amount of information that I gave him. I think it is all credit to Ashley to be able to. I think a lot of the information he got wasn't from me. It was he had to really work for it through external folks.
That's interesting.
He didn't bring that up when he was on this show.
No, he didn't. Yeah. I'm curious, but so when he did come in, though, I would love to hear sort of what it's like from your perspective. When you bring a journalist in like that, what is that like to have? Does it? I mean, I guess you probably hope it doesn't change your behavior in any way to have an observer, but it always kind of does in a little bit. So I'm curious to see, what is that like to kind of have someone who's paying attention to everything you're doing, and do you learn anything from them about what they choose to write down? I guess that's a question, right?
Oh, look, I mean, not really. I mean, so Ashley didn't spend a huge amount of time, with us. And I guess it's fair to say you're always conscious, when you're talking to folks. But what you see is what you get here. There's no creation going on, really. I mean, so. I mean, we are what we are. We've got our faults. We do some stuff well, we do some stuff poorly, and it is what it is. And that's just how it is.
Yeah. Cool.
How did you feel about the peers that were written about in that book? Like the set, that he selected. Were you like, all right, I get the theme here?
Yeah, I think it was a good set. Yeah, no, I thought it was a good set. I would have liked to seen Virgin Orbit in there, to be honest. Because look, I remember when I started Rocket Lab, Virgin Orbit was still Virgin Galactic at that point, and I can remember going around all the VC firms, and the number one question I got, it's like, okay, you're from New Zealand, your country has no industry, you're raising a relatively small amount of money to compete with this, being Virgin, and we were never ever the perceived winner in that small launch game. Virgin Orbit raised exactly $1.1 billion more than we did to get to first orbit. So, so it would have been great to see Virgin Orbit's story in there, because I think that was kind of the missing element, because everywhere I went to try and raise money, they were the preordained winners.
That's really interesting.
So there's a little extra behind the factory purchase, is what you're telling us. Just a little. There's a little good feeling behind it.
No comment.
Fair enough. Long Beach is nice, I think.
Yeah.
That's one of the ones in Long Beach, right?
But I mean, looking truthful, I think it's pleasing that all of that work and all of that infrastructure and all of that capital is now being put to work flat out on Neutron and other things. So, it's in one respect it died, in another respect it was reborn. So so I think all of the people that work so hard there should certainly take solace in the fact that all of their work has not gone in vain.
Yeah. I do love that you got the money either way. That's lovely. That's a nice ironic win. I love it.
It comes back around.
Yeah, totally.
Yeah, I mean, Neutron is definitely a whole wing of the show we should probably get into, because you're at an interesting moment. Last time we talked, it was early days for the world knowing about Neutron, and now you're in the depths of it at this moment. So can you maybe back off that and just kind of give us an understanding for what the Neutron setup is going to be when this thing is totally rolling? Like, is that facility out in California home of Neutron production and all of that, and then it would be heading over to Wallops for launch? Or is there going to be, I know there's a new facility out in the Maryland area or something. I just kind of trying to understand the map that you've got going.
Yeah, 100%. So firstly, I'd say that whenever somebody looks at a rocket program, everybody looks at the rocket, and I would say that the rocket is probably 20% of the work and the capital. 80% of the work in the capital is everything else, the infrastructure around the actual rocket. So, as you say, factories, launch sites, engine test facilities. So kind of the general gist there is that, so Long Beach facility, the old Virgin facility, is now called the Engine Development Center, or EDC. And that currently produces Electron's Rutherford engine and all of the Neutron Archimedes engines. So that's an end-to-end production line just spitting all of those engines out. Then we have the Middle River facility, where we have our very large automated fiber placement machine, which is, think of it like almost like a 3D printer for composite. And instead of printing 0.1 of a millimeter at a time, you're literally laying down meters a minute of carbon fiber in big wide strafes. So
those are like the spinner weave things, right?
No. So it's a tape winder, so a tape layer. So think of like a giant mold, and then a CNC machine and head, and basically the head just zips in there, laying down, fiber backwards and forwards and backwards and forwards. So very, very efficient, massively efficient. And look, used tremendously in the aviation industry for making fuselages and tailplanes and all those kinds of things. But like I say, you measure it in like meters of carbon fiber laid per minute. It's just awesome. So the Middle River facility is really doing those large composite structures and some integration. Then the integration facility just outside the gate of Wallops does the final assembly of the launch vehicle. And then spread around the various other facilities, we have kind of component level stuff and component level development. Like down here in New Zealand, there's a whole bunch of kind of TVCs and bits and pieces spread across there. And then of course, in Mississippi, we have the engine test facility. So that's where all the engines go to test. So it's kind of a little bit spread out, but actually pretty concentrated on the East Coast in a lot of respects. And that's kind of the gist of it. Now, the lovely thing about Middle River is it's an old Lockheed building that used to build Geminis, I think it was. So it's right on, So it's right on the water, and the rocket literally rolls out onto the barge. The barge rolls up to just up the sea to Wallops, and then we're right there at the pad. So from a logistics standpoint, really, really efficient.
I was going to ask that because I was like, it's obviously very close to Wallops. I was like, can you put that on a highway? I don't know if you can. It's probably too big for the highway, right? So yeah, you got a boat to just go through the bay or whatever, right?
Yeah, exactly. Well, you guys know how much I love marine assets, so I'm making sure that I get the maximum use out of our marine assets possible.
I love it.
Jake, we were talking on the pre-show about how big the U.S. is and how much space we've got, and the fact that you think that is close to Wallops is hilarious. As someone who has driven that length many times, it's not close to Wallops. It's close if you zoom out. It's not.
Okay, but like in the grand scheme of rockets, in the grand scheme
Fair.
of rockets,
Yeah,
it's
fair.
a lot closer than Falcon is to its launch pod. It's a
Yeah.
lot closer than Vulcan is to its launch pad. It's a lot closer than Saturn or Shuttle ever were.
Mhm.
It's close for rockets.
That's fair.
Yeah,
Those
yeah,
ULA
yeah.
rockets, they
Yeah.
they take boats on rivers for a long distance. So
yeah.
Yeah.
So yeah,
That's fair.
I know that like New Zealand has such a rich heritage in like composites for like sailing ships and stuff. Did you manage? Is like does any of that heritage and skill and talent, has any of that been able to be transferred into your operation in the United States? Like, is there if a New Zealander who makes those ships came into your rocket family, would he be able to, your rocket factory, would he be able to point out stuff that's like, oh yeah, that's how we do it? Like, is there any kind of like character to that managed to transfer over?
Definitely. So, I mean, even in my background, when I was working for a government research institute, it was in supporting advanced composite structures for the America's Cup boats. So even my grounding is kind of there. But yes, I would say that look, New Zealand has an international reputation of doing very difficult and unique things with carbon composite structures, and look, the US obviously has unique capabilities as well. So it's not unusual to see Kiwis running around our US composite factories and facilities for sure. So no, yeah, I think it's a very seamless seamless integration there.
Good.
Let's keep carbon fiber theme for a minute, because so you've got Electron and Neutron, big size difference here. Are there? I'm curious to know, in the era that we're in now, where Starship is doing its thing as a stainless steel rocket, and there was a whole branch of its history that was going to be carbon fiber, and it's still like the one question I want to ask Elon Musk of like the day that they decided to make that switch, or the day they like officially said, we're switching, we're trashing that big mandrel thing that Jake was talking about. We're going stainless steel direction. And I feel like that's been explained in various ways throughout the years, but I'm curious, in the life cycle of Neutron design, did you put up other options when you were thinking about a bigger rocket? And what was it that said, no, what we started with the carbon fiber branch here is the right decision for something as big as Neutron?
Oh, absolutely. So here's the thing: like, there's no silver bullet in this industry, right? Everything is an engineering compromise.
Yes.
Yeah. Everything is a compromise, right? So the advantage with stainless steel is so thermally it's got some great resistance. But the advantage with it is that if you want to iterate quickly, you can just weld stuff together and move and change designs very, very quickly. Now, the downside with composites is you have to build the tooling to make the part. So when you build the tooling, it's very difficult to iterate on that kind of outer mold line, if you will, because it's new tooling. So that would make an iterative process very, very slow. Now, the disadvantage with stainless steel is it's 4 times heavier per unit strength than carbon fiber. So for the same strength, it's 4 times the weight. Now, the advantage with carbon fiber, obviously, is it's 4 times lighter for the same mass. So there's pluses and minuses. Now, if I'm Elon and I'm looking at Starship, where you're going to be doing a tremendous amount of iterative design, then it's not feasible to build it out of composite, because the time it takes to build the tooling would not be conducive to a highly iterative approach. Stainless steel is wonderful, but the challenge with the stainless steel is it's very, very heavy. So where that drives other trades is now you have to have extremely high performance propulsion systems. So you put all of the kind of compromise, if you will. Now you've got heavy structures. You just have heavy structures. So if you've got heavy structures, then you need higher ISP and higher thrust and higher performance out of your engine. And that's the trade you make. Now, the trade we made with Neutron is we know exactly the vehicle we want to build. There is no iteration cycle that's required. So we're happy to go in and tool that thing straight away. Now, we end up with very, very lightweight structures, incredibly lightweight structures. I mean, the whole upper stage 5-meter diameter tank of Neutron weighs the same amount as a Harley Davidson. So, and everybody, you look. You
Oh,
look
yes.
at like
It's not just the Americans that the weird unit of matters, everybody. All right? Listen, back off.
Yeah,
Get out of here with the
exactly.
dishwashers and my football fields. We got a new one.
Yeah, yeah,
Harley
yeah.
Davidsons. I love it. Yeah.
Exactly. And you think of Centaur's light, and it really is an amazing thing. But the neutron upper stage makes Centaur look like an obese person. So
It looks like he was trying to think of a big motorcycle and couldn't think of a bigger motorcycle than a Harley Davidson.
A rocket bike, maybe. Yeah.
It's like a rocket bike.
Yeah. But what that means for us, though, is that if you kind of break it all down and you're trying to build a reusable rocket, what is the bit that, from a reusability standpoint, is the most complex? And that's the propulsion system. It's engines. So what it enabled us to do is it enabled us to build engines that have a very, very benign operating point. Because our structures are so light, our performance out of our engines need to be very modest. And like if you're sitting on an aircraft and you're flying across the Pacific Ocean, hopefully coming to visit me in New Zealand one day, and you look out on the wing at that turbine, you do not want that turbine running on the ragged edge, riding the lightning. You want that turbine just sitting in a real comfortable place. And that's exactly what we've been able to achieve with Neutron, is those engines, their life will be measured not in seconds, not in minutes, but in hours, if not more. So that was the engineering compromise that we made. So we traded lightweight structures, for put the challenge in the structures and taken all the challenge out of the engine.
So does that mean like you're coming to the end of well, maybe not the end, but you're deep into the development cycle for Archimedes, and do you find that played out? Like, do you find that the development of that engine, because it didn't have to push so many boundaries, like did it happen easily and quicker than it may have had you gone a different direction? Like, do you feel like that played out?
Yeah, look, engine design is always complex. But we weren't worried. I mean, we were lucky to have a whole bunch of the SpaceX Raptor team came and joined us to develop Archimedes, and they're not trying to do pre-burners at 11,000 psi, and okay, a chamber pressure is like 2,000 psi, so that makes it's just a totally different. Our biggest challenge to date with Archimedes is actually getting the pre-burner to operate so cold, not so hot. Because it's such a benign operating point that that was actually the challenge of the pre-burner elements, was to get them to light and run reliably at such cold temperatures.
That's interesting.
I don't even know what to do with that one, to be honest. Not smart enough.
Yeah, but that's where you want to be, right? Like, that's where you want to be. You don't want to be worrying about melting your turbine off. You want to be at the other point of that design envelope.
Does that also mean, though, that you have headroom there, and that's something that you and the team would plan to like eat into eventually if you want to get to a reusable upper stage or something that's more complex, or human launch vehicles, or things that would use up that other margin? Like, is that something that you kind of keep in the back of your head? Is it something that you would plan on?
Well, yes, yeah. We could, but it kind of defeats the purpose. What we're trying to build here is just an incredibly, efficient, reusable rocket. And the moment you start cranking this thing up, then everything is a giant trade. And I want an engine that I can land the stage back and bring it back, walk up to it, do a couple of visual inspections, and carry on. That's where we need to be. So
you want the Toyota Corolla of rockets, basically.
Yeah.
I believe you, but also see Electron. I think it was one of the early shows. I was like, "You're gonna stretch this thing at all?" And you're like, "Nah, we like the height of it." And I was like, "All right." And then I was like, "Well, I don't think he was lying to me, but certainly things change in Electron over time, and that's a natural flow of things, and it's."
Oh, look! Don't get me wrong. Like it totally will change. But I guess the reusability and the kind of reliability design ethos is fundamental.
That's like the tentpole of this versus where Electron was coming from. Yeah,
exactly. So I'd be disappointed if we ended up with an engine that was a grenade, and everything was just pushed to the absolute limits, that would be a failure of the program, in my opinion. And but yeah, look. Also, we always joke here at Rocket Lab. It's like nobody ever asked for more thrust. I mean, that of course everybody asks for more thrust. I mean, there's always other areas of launch vehicle that don't meet the performance that you hope for. But I mean, yeah, certainly modest improvements of those kinds of things are very easy gains. But we hope we end up in that design envelope that we really want to be.
Yeah. So a lot of people are curious about the launch date, obviously. Is 2024 still on the table? Do you think this thing's coming up, or is there changes to that? Because I know I've heard that date, and a lot of people are skeptical of it. I might be skeptical of it too. So I'm curious to see what you think about it.
I don't think Peter's surprised that none of us believe launch dates, Jake. Like just generally across the board. I mostly ignored dates, to be fair. So
yeah. No, look, we already updated that. I think last earnings call we're targeting for mid 25 now.
Mid 25.
Yeah. So
that's still pretty soon.
It is, and we say to everybody, this is their dates, this is their targets, but it's a rocket program. And sometimes you get dealt a happy card, happy deck of cards, and sometimes you don't. And I would say that as every day goes by, we get greater and greater visibility to that launch date and the probability thereof as we move further and further down the program. So, but I mean, also saying that. You can get right to the very end in an all-integrated stage test and have an issue. So, that's our target. That's where we think it's landing right now. But also, I think we're always cautious that it's a rocket program.
One of the things we've been talking about on the show recently with like Artemis and Vulcan and some of these other vehicles that are out there is the way that manifests build out and how. We've almost started joking that like the distance between the second and third launch is the most telling aspect of like an architecture like Artemis or Vulcan situation that they're in with the payloads shifting and needing engines and all this, that you might know we're not gonna be able to get to our third launch until really far in the distance. So the second launch is gonna be delayed a bit and it will fill that gap. And like you kind of have this thing in early programs where stuff predictably happens at the first mission or two. And it kind of obfuscates the fact that mission 3 is farther away. Now, in the Rocket Lab world, even with Electron early days, you were talking about, when competitors were out there still talking about their first launch, you were really harping on, yes, but it's this whole production line, it's the operations, it's flying with pace. So knowing that that's Rocket Lab's situation over the years, what was it that came out of like the Electron world and fed into Neutron in terms of planning? Did you plan stuff differently this time, having that whole Electron rep in your past?
100%. And we've been very public with what we expect about the Neutron launch cadence. It's like 1, 3, 5. So it's in those are years, like one and then 3 in the next year. Nobody
Not
could
1
expect
and 12.
to do better than that. Oh my God, no! It's an insanity. Like, I mean,
1, 12,
who's
16.
doing that?
Yeah.
Yeah. So, and look, I feel like a bit of an old person in the industry now. I've even got the grey hairs to prove it. I mean, I can remember sitting on the stage at a space symposium, proclaiming that how we were going to commoditize launch and all this, and man, like, there's nothing like the launch gods to bring a baseball bat to your face and kind of put you into reality, and this is why like productionizing a rocket, or productionizing anything to that matter, but a rocket especially, is just vastly more complicated than putting your first one on the pad. And I look back at Electron and it's all that really unsexy stuff, like supply chain, ERP systems, MRP systems, work instructions, quality. These are all the things that nobody ever sees, but are the things that make a production line go. And your first rocket, you have all of your engineers poring over it in the most excruciating detail, taking care of absolutely every little thing, knowing everything there is to know about the design of how something should be. And then on your 20th rocket, you have technicians reading work instructions, and some of those technicians can be brand new, that have just arrived and are in training, but yet everything has to be flawless. And creating a production system to allow that, and is so difficult, but also really transferable. So, the production system we developed for Electron is what we use in our space systems, and it's also what we're using for Neutron. So a lot of that base infrastructure, all of that base infrastructure is kind of built. So we feel very, very, very privileged to have that. But when you're going from zero as a new rocket company, it is I would say, if I could go back in time and give myself one piece of advice, it would be prepare for how hard this is.
Yeah. It is. I fully believe. Like, I have no problem believing anything you just said there. Like, that is such a hard issue. I mean, it's documentation, it's training, it's like a culture. It's getting people to have a system that can accommodate people who make mistakes or quit or are slow or whatever. Like, you have to have something that's robust to
or drink wine at 8
not
a.m. on
your
Fridays.
Yeah. What if your CEO drinks wine at 8 a.m. on a Friday? Does the system still work in time? Like, you have to have all that,
unfair.
right?
It's totally unfair. You guys are creating a persona that you know what? I can only drink one glass of wine. I'm anybody's after one glass of wine.
That's fine.
I mean, there's probably time for someone behind the camera here to go and grab one for you before we get to the end of the show. I'm just going to say that one out loud there. So,
with how good the set looks, they got time to do all sorts of stuff. The lighting's great. This is the best lighting anyone's had on the show. So,
yeah,
we've had professional YouTubers. So,
Well, it's all down to James. He runs all of the live streams, and I think, talk about, you guys know, right? You guys know what it takes to put a live stream together, and there's a tiny little team here at Rocket Lab that produce all of our live streams, and they do a great job.
Shout out to the people running the tech. Yeah. One thing you were getting at, and I'm curious about, is like the thing that when you think back, you wish you did different with Electron out the gate, and what if any of those are still lingering? Like, is there a thing that is on Electron that the engineers are like, man, if we could just solve this one thing or tweak that, or I wish we made a different decision here? What are the things that bug you and the team?
What's the Electron tech debt?
Yeah, that's a good way to put it.
Yeah. Well, look, to be honest with you, I don't look at things like that, because all the decisions we made were made at the right with the right information at the right time. And look, I'm sure there's I can think of a number of things that I would love to have a better yield, or we could have done differently. But honestly, I think the team did an amazing job, because the first Electron that flew and the number 50 that's on the pad right now, if you guys stood in front of those two vehicles and looked at it, they don't look any different. Like, there was no massive redesigns of any system. There was no minimum viable product just to get to the pad to show some investors we could do it kind of a gig. Like, that thing was built for production on day one.
You did make 50.
And
so it's like, that's a thing.
Yeah. And it's like, look, there's always things that with infinite time and infinite capital you could streamline and whatnot. But I think that has been some of the magic and the success of Rocket Lab is, we have a core fundamental belief here is build beautiful things. And it's kind of like Archimedes as well. Like, we could have put a billet copper chamber on a test stand and made some fire a year ago. And look great for an investment pitch or anything like that. No. We put the engine on that stand that is in production. So, and that's the difference, right? That's what makes it important. So that the Archimedes engine that's there now is gonna look the same as the Archimedes engine that's gonna go in orbit. So that's kind of our approach here is like, focus on the engineering, focus on the end goal, and don't get kind of polluted by kind of perverse, fake goals on the way through.
That's interesting.
I like the classification of fake goals.
Fake goals,
I'm thinking in that framework. That's a good one. Yeah. Have you had any fake goals crop up that you were like, no, I realize now that's a fake goal. We should stop doing that plan. Like, is there anything that's come up in the past?
Oh, look, I'm sure, because sometimes sometimes you want to achieve something and feel like you're achieving something, and this is the challenge, right? And this is why I say Neutron right now it's the best part of the program, because for like the first year and a bit, it's just all in CAD land, right? We're designing the rocket, and before we can make any of the toolings, the design of the rocket has to be finished. So you have to be very, very mature in your rocket design before you cut tooling for a composite rocket. So it feels like nothing happened. I mean, probably does for the rest of the world on the outside, like nothing happened for a year on Neutron. But actually, it all happened in the first year. It's just no hardware. And right now I say we're in the best time, because all of the stuff is in our hands, and we're testing hardware flat out. And look, it's super exciting to see hardware turn up, and all full of hope and promise, and you think it's going to be perfect. And then now I'd say we're kind of in this honeymoon period where that is the case, but we're also learning what isn't perfect, and what are the iteration cycles we need to do on particular pieces of things. So we're transitioning out of the hardware not hardware, the kind of honeymoon period, into what is generally a pretty brutal period, where you learn that actually that bit's not performing the way you want it to, and you got to go back and fix it and so forth. So
yeah,
I'd say everybody work on the new program and enjoy right now, because it's all downhill.
Yeah, once you get into that integration stuff, it can go really off the rails, right? So
yep. But the good news is then it goes uphill very quickly, because once you're integrating and on the pad, then there's definitely a trough out, that's for sure.
Yeah. So should we talk about some not rocket stuff? There's I always make a joke that we have to stop calling Rocket Lab a rocket company, because you're doing lots of other stuff now, maybe even more stuff than you are rockets. So I have a duty as a Planetary rep on this co-host duo to ask about a couple things. I want to start with Escapade, because are you still involved with the bus for that and everything? That's still all go for you guys? It's been changed a lot, so I'm trying to keep track.
Yeah, no, we built the whole thing. So no, yeah. Escapade is oh man, there's photos of it online. It's the most beautiful spacecraft. Seriously, I mean, whenever I go to headquarters, I literally walk straight past my desk, gown a clean room gown, and just go straight to Escapade in the clean room, because that thing's going to Mars. The team has designed and built the most beautiful spacecraft. And so, yep, that is, we are on track to deliver that for launch, and it's launching on the Blue Origin's first vehicle. So we are, like I say, we are on track to deliver that spacecraft.
We got to get that picture up there.
I'm working on it.
Two of them, yes.
This is the one I'm talking about. This is a big old. Is this the most? I don't know. This is the one that's on the site, but maybe this isn't recent enough.
Yeah. I can't actually see it.
Oh, you can't? There you go.
Yeah. Yep. Oh, There's better pictures than that, though. Yeah.
All right, I'll keep Googling. Jeez.
We'll keep Googling. That's awesome. I mean, I'm curious. So you got that, and we have Venus. I think Venus is scheduled for, I would say, next year, right? That's kind of where we're at with that one, or end of this year, early next year?
Yeah. Well, look. Venus is a passion project, and it's a nights and weekends thing. And of course, the challenge with Venus is that we've got $500 million SDA contract to deliver. We've got MDA Global Stars spacecraft to deliver. We've got the two Escapade spacecraft to deliver. Whole bunch of VADA spacecraft to deliver. So it's always kind of the poor uncle to all of the real work. So No, look, it's a huge passion of mine, and we continue to work on it. But we have to run the business first, and it kind of. So look, if it happens next year, that'll be great. If it doesn't, Venus isn't going anywhere, and we'll get to it. But we have to deliver the projects first.
So I'm curious though, because those are two missions that go to domains that most of your other stuff is sticking around Earth, kind of thing, right? I mean, you got some components on things like I think you got solar panels on Psyche, is it? I think are out there. That's your stuff. But I mean, but the bigger question is, what are you learning from exploring the solar system as you're building those systems to work in those environments? I'm curious to know if there's any kind of feedback loop between systems going back to quote unquote the real work that you say, right? Yeah, as you're going back and building these other satellites and rocket stuff. I'm kind of curious to know, like, what technologically, from an engineering standpoint, what's going back and forth between those kind of things, because they kind of seem like different domains, and it's a topic I'm kind of interested in.
Yeah. So what I will say is, if you can build 2 spacecraft to go to Mars and operate around Mars, you can pretty much build anything. And that's kind of the one of the reasons why I was so keen to do the project, apart from like an unhinged kind of planetary desire, really. And we really focus on doing the difficult stuff. I mean, if you look at all of our spacecraft and all of our programs, they're all crazy difficult. So Escapade, great example. Take Varda. I mean, that is a platform that hosts a capsule. We are responsible for all the trajectory and propulsion and targeting to re-enter that capsule and land it in the desert. Ridiculously hard thing to do. It's a spacecraft that has a big ball of propulsion on board and a whole bunch of power to run their factory. That is not a basic bus. Really difficult. The MDA Globalstar mission, like, very, very long lifespan, operating in an incredibly difficult radiation environment. This is not your small sat bus, right? These are half-ton things wallowing in the worst radiation you can imagine, that require an uptime of extremely high. So once again, really difficult. So we never, and Capstone to the Moon was another great example, crazy difficult. So we do this really difficult stuff because we're really good at that really difficult stuff. But what it does mean is you're kind of right. It's like you do these difficult things, and then everything else becomes relatively simple after that. And what I'm trying to build here is an end-to-end space company. And I think that the large space companies of the future are not going to be a company that just focuses on launch or just focuses on building satellites. The large space companies of the future are going to look like Rocket Lab, where a customer comes to you and says, "Hey, I want some telecommunications over Brazil." And you go, "Okay." And you build the satellite, you deploy the satellite, you operate the satellite, and you just provide that service. Because anybody who wants to provide a service from space have to become like domain experts in how to build a satellite and how to launch a rocket and how to operate in space. And like the barrier there is extraordinarily high. And I think you can look at the Starlink example, right? I mean, nobody can compete with internet from space unless you have your ability to build your own satellites, your ability to launch them on your own rocket, and at scale. And we're trying to, and we're arguing we've built the same kind of model there. Is we can go to Mars. So if you want to do a comms satellite in low Earth orbit, like, no deal at all, no big deal at all. That's piece of cake. And we'll have Neutron online shortly, and we can deploy those in mass with Neutron. So I really think that is what we're trying to build, and that's what all the large space companies of the future are going to look like. I think we will quickly remove this idea of just a launch company or just a satellite company.
Yeah. Emphasis on the lab.
Yeah. A future rebrand,
Well, do you know the
just drop the
story?
rocket. Yeah, that's great.
Well, do you
This
know the
lab.
story with the name Rocket Lab? How it came about?
Well, I think from reading the book, wasn't there like it kind of had a start in sort of like that. You worked for that think tank or whatever it was, and you were really kind of kicking around lots of ideas and stuff, weren't you? And then your barn with all your
Yeah, well, no, I mean, as I was sitting on the plane on back from my rocket pilgrimage in America, starting Rocket Lab, you know, shows how kind of innovative I am in that respect in the naming convention. But what am I doing? Rocket, and I was worried that I'm this Kiwi from a country there's no rocket experience. I have no aerospace degree. I needed something that would give us a little bit of credibility. So call something laboratory, and all of a sudden it sounds like sciencey and techie, and so Rocket Lab. Yep, that works. And that was the name.
I have a very Canadian analogy to that exact thinking. So I used to live in Edmonton, Alberta, and back when Alberta was becoming a province, they were trying to pick the capital of this province, and all the cities were sort of applying. So Edmonton got the job, and the way they did it is in their application, it said, where are you going to put the legislature? And so they were still like naming the streets. It was like a very small town. And so instead of the middle of their town being like, like Main Street or whatever, and then going like first, second, third, they made the middle 100th and 100th. And then it made it, so the legislature address was going to be like whatever 100th Avenue. And that made the city look a lot bigger than it actually was.
There you go. Nice.
There was two options. It was name it after the guy picking, or prop it up a lot. Yeah.
No, that never works. That's never.
A small tangent question on the planetary stuff, just because I have you on the horn here, and I want to take the opportunity.
Yep.
Mars, Venus, Moon, all of those have some degree of planetary protection requirements, and I'm really curious to hear a perspective from a service provider. How is it working with those policies? Because they're kind of a weird mishmash of not quite clear things, and it's not super clear who's in charge of them half the time, and it seems like an interesting requirement to work with. And I'm just kind of curious to know, how did that impact your design decisions, and is it easy to work with? Was it difficult? I don't know. I want to hear your perspective on that.
Yeah, look, so it's pretty easy for us because they're, at least the capstone and the Mars missions are NASA. So we just follow the NASA planetary standards. And I don't know, call me a geek, but I think it's quite cool. I love the fact that when I go into the clean room to go and look at Escapade, I have to go through an extra layer of planetary protection so that I don't put peat germs on Mars. I think that's just cool. So no, and look, I think it's responsible. So look, maybe there's other members of the team that have to experience it that I don't, but I think that's fine. I mean, I think the interesting one is going to be Mars sample return. It's going to be interesting because we of course you don't want to bring anything to Mars equally well. If you're bringing something back, it should be dead, right? But I think that's kind of a new thing. I think planetary protection is kind of inverted in that sense. That'll be a really interesting one to follow.
Yeah, I know it's a I don't say a policy, but it's a practice that's been undergoing a lot of changes over the last few years. Call it 5 years or so. Planetary protection's it's had a lot of eyes on it, mostly because there's lots of different things happening. One of those being people like you are getting into the space, and even if it's a NASA mission, it's never been like that before, right? And you've got Mars sample return. That's going to be the that's on the list of places to go and things to do. That's the highest level of stringent requirements you're going to get, right? And we've never done that before, so there's lots of stuff happening in that world. And so I was just kind of curious to see what you think of that. But
yeah.
I mean, lightning. I was gonna say lightning. I wasn't plugging your satellite bus, but if you want
you
to
go for gold.
No, I was gonna lightning round things I've been thinking about with regards to various Rocket Lab projects over the years. One is there was a thing like a year or two ago where Rocket Lab got some sort of agreement with NASA to look at payload return from low Earth orbit or something like that, and I feel like I never got full resolution on this. Was I having a fever dream, or was this actually a thing that happened?
You might have been confused because we had a Space Act agreement with NASA, and we still do, on the Venus entry probe on the heat shield. So using some of their new materials for our probe for the Venus mission. So that's the only thing I can think of that that might be aligned there. Obviously we do the VADA re-entry stuff, but
the paperwork seemed more interesting on that one than the space side of things. This thing hung up there for a couple of months.
Yeah. No, look, and all credit to VADA. They're pushing the boundaries and doing new stuff, and so I think there was a lot of learning that had to be done there, and they managed to get through it.
Next, random Anthony's bugged about this thing. I maybe this is my failure of imagination of how big Neutron is actually going to be, and I need to just let me know next time you're in Virginia, and I will drive down. It's very close, as Jake said, so it'll be a quick drive.
Just
I cannot figure out the size of the fairing on this thing. Something about it, I feel like it looks too small, but maybe I'm just not sure of where the second stage ends and the fairing technically begins. There's like a tube part of this. So can you give us some estimates or like comparisons between what the effective area would be in there versus some of the other competitors in that 5 meter class at the moment?
It's all on par with all 5 meter class. So you're exactly right. So you have to understand that we no longer have fairings. We have a nose cone. Because the fairings aren't jettisoned, the nose cone is just an aerodynamic inconvenience, and so it just needs to do the job of a nose cone. So yes, no, a lot of the payload is buried sort of deeper into the interstage. Well, that's probably quite an old image too. We're not that
you always say that every time I talk about images. No. You always say, that one's out of date. So
I know, but we more worried about building the rocket than creating images. But yes, you're actually right. That is it is buried within that interstage a bit, because from an engineering perspective, we want to keep the opening of those, the actual items we're opening to the lowest mass possible, because we obviously the larger the shell that you have to open, the more challenge you have with stiffness and location. So like I say, they're just an aerodynamic inconvenience, and we just need to actuate them as actuate the minimum amount possible. So the most efficient way is to suck the payload down a little bit. And
but is this like comparable with the short fairings on Falcon 9 or Vulcan, or I guess old Atlas V, like the shorter fairings, but not necessarily the extended Falcon 9 fairings or the super long Vulcan fairings?
No, I have to I'll get back to you on that, exactly where we landed on that. But I mean, it's all kind of customer driven anyway, and you have to, a lot of the constellation is all pretty short stack anyway.
It's mass limited first in a lot of the cases.
100%. And it's like any of these design points. Everything is a trade, right? Everything is a giant trade-off. So you can very easily find yourself in a situation where for a payload that represents 3% of the market, you remove 20% of the rocket's performance. So all of those trades and decisions around those kind of things are very, very much customer led, and also being grown up about. There will be some mission that might be a 3% of a particular category of missions that we just can't do, and that's fine because they represent 3% of the total market, and someone else can do those.
Love it.
I feel like you're doing fine in the NRO department anyway, so I feel like they'll be fine with it.
Yep.
They would be happy if the entire rocket was a fairing. That's kind of where they're
Yeah,
at,
yeah,
know. So
yeah.
they'll figure out what to do with it. All right. So what's you're talking some trash about this drawing? Can you tell us? Can you describe with words what is new now? You're saying this is out of date. What's the current Neutron looking like these days?
Well, it's looking pretty similar to that. Strakes are slightly different. Canards slightly. Fairings are definitely slightly different. I mean, they're all just sort of tweaks. One thing I would say is you notice the upper stage. This is cool. So you notice the second stage is actually really tiny compared to the first stage, and that's I guess that's a bit of a hint at the design element here is like put all the most amount of energy you can into the first stage, because the first stage is the bit that you're reusing. So with a non-reusable upper stage, you have like a really competing set of requirements, right? It has to be the highest performance and the lowest cost. Now, generally those two things, collide. They don't converge. So what that means is for it to be the lowest cost, you need it to be really, really small and efficient. And that's the thing that you always see is like the upper stage compared to the first stage looks really small, because the first stage is just doing so much work, as it should, because that's the bit that we're bringing back and reusing again and again.
Doesn't that put you into the area though where re-entry and recovery starts to get harder, right? There's a tipping point somewhere in there where if you've got too much velocity in the first stage, it makes your work a lot harder. So how do you actually dial in that balance?
The Vulcan problem, yeah.
The Vulcan problem, what do you always call it's like the groundlet upper stage, Jake's theory on SLS and delta to some extent.
Yeah. No, look, as I mentioned, everything is a trade, and like if all the engineers are sitting in the room of every leaders of every discipline and they're all unhappy, then I know I've done my job exactly right.
They all think the other should be solving their problem, then you're in a good spot.
Yep. Yeah. That's how you've reached optimum design point. But yeah, so the interesting thing about Neutron as well is we don't have a deceleration burn. And we've been able to do that from the learnings from Electron, because obviously Electron has no burn at any point. So we've really mastered how to re-enter these kind of things without kind of doing these deceleration burns and kind of scrubbing off the velocity in that sense. So the Neutron is unique in that factor as well.
Okay.
No.
Yeah.
All right. When can I come down to visit? when are you in Virginia next? Is my final question of like, let me.
Oh, look, I'm all over the states, all over the world, all of the time. So if we can get a calendar sync, that'd be great. But yeah.
I mean, mid 2025, I'm there for sure.
I think
so.
Mid 2025.
Wallops, man, is such a. I always tell Jake, like when you go to see something there, it's great because it's like minor league Kennedy in the way that everything's a little closer and a little easier to access, and like the press site is arguably too close and it's really loud. Even the first Electron I saw from there, I was like, damn, that thing's got a kick to it. I didn't know. I've seen Antares from there before, but I didn't know what it would. No one, I don't think at that point anyone had seen, other than the team, had seen Electron from that close, because the New Zealand site, you're pretty far out there. Although you're going to bring some launch photographers there. I don't know. People were asking if you've selected the photographers that are heading down, or if that's still a process.
Yeah, I'm not sure if we have it or not, but no, it'll be. Looking forward to that. It'll be a good opportunity. Yeah.
Some good picks.
Cool.
Ariane Space needs to take a note out of that there. It's another one that's the only thing that beats out how far you can watch an Electron from New Zealand is how far you watch an Ariane 5 or 6 from French Guiana. It is like from people that have been, it's forever away. So
yeah, right.
Yeah, they're solving that at Wallops. Neutron, are we going to be able to stand that close for Neutron at Wallops?
Yeah, I mean,
it's a big ass rocket. We're gonna be like 2 miles away from that thing.
Yeah. I mean, all the hazard arcs are all within limits. So yeah, no, I
Nice.
think
That's gonna be the
that'd be good.
best.
no, it should be
Yes. Hell yeah.
Good. Good.
That's the shit. Well,
Well, this has been
we
fun.
appreciate hanging out. Yeah, always.
Yeah,
always great
likewise.
to
Yeah,
hang out and
super
get
fun.
some questions asked. We kept Jake's Planetary. We scratched his itch a little bit. So
Yeah, a little bit. Yeah.
Yeah, no,
I just want to
well,
see him fly. I can't wait.
yeah, me too. Yeah, no, I love Escapade is going to be an awesome mission. It's going to be really cool.
what are you gonna visit next when Escapade's out the door? What's the thing you're gonna go?
Europa.
Yeah,
no, I meant
well,
like
I mean,
when he goes into
yes.
work. He said he goes and visits Escapade. What are you gonna do now?
Well, we always this is the thing is we always have to have one interplanetary mission in the clean room, right?
Just for your like
for sneak
morning
cred,
ritual.
yeah, my morning ritual. Yeah, no, I think look, it's inspiring. It's super inspiring, and it's hard to explain until you actually stand there and you go, man, this thing's going to another planet. Like, that's cool. That's real cool.
Yeah. Nailed it.
Nice.
Perfect ending.
All right, y'all. What do we got next week, Jake? Is next week Vulcan week?
I think next week is Vulcan week. Yeah. So we're doing a bit of a tour of rocket executives. So we're gonna have someone from ULA come on. Mark Peller's coming on, and we're gonna talk about Vulcan, and we're gonna ask him all the same questions about production.
The difference between the second and third launch. That's the big one.
Second and third launch. Yeah.
Yeah. Oh, Mark's great. Mark is great. So that'll be a great. I'll look forward to watching that show.
Nice.
Yeah, we're excited to have him. So cool. All right. Well, Peter, thanks so much for coming on. This has been great. We appreciate the time, and good luck with Launch 50.
Thanks very much. Look forward to it.
See you.
Bye, everyone.